Hi. So I've been repairing C5 boards for a little while for people on the Facebook groups, and I thought I'd try and make a video of showing you through the process of diagnosing problems with these and fixing them, see if it can potentially help someone else. So I've got a pod and a control box that's just come in, which is faulty. First thing I'll do is give them a quick visual inspection for common problems. So we'll check the bottom, make sure there's no dry joints, especially along the pod connector along here and on the thermistor and the thermal cutout here, because these are quite commonly go dry where connectors have been pulled in and out. So these look pretty good. On the flip side, we can see, okay, so one of the fuses is blown, so I'll have to replace that. And then the other common fault you can see on this one is R1 has been burnt out, and that's normally caused by the battery being connected the wrong way around. So we'll replace R1, and we'll also have to check this voltage regulator, because commonly when this goes, this gets burnt out as well, and I'll show you how to test that in a moment. The other one to check is D1. If the C5 is pushed backwards too fast, it can usually cause damage to this. So these we can easily test with a voltmeter if we put it on the diode setting, and then we can just check. You should get polarity through one way, and the other way it should just beep. So we can see here D1 is also blown. If I just compare that to a new component, which I have here, so one way around you just get a beep, and it sits at about 5.5 volts there, I think you can just about see. And if I turn it around the other way, you get nothing, no continuity. That's how it should be, so that's definitely faulty as well. So replace D1, replace R1, we'll test the voltage regulator once we've changed those. And the other two, there's two diodes here which I always just give a quick check. So that's good at 5.5 volts. And this one is widened the other way around, so there should be nothing this way. Oh, full continuity that way, and 0.5 the other. So it looks like this one's gone as well. So that one is D3. So we'll replace D3, D1, R1, replace the fuse, and then we'll power it up and see where we are. So I'll just go ahead and replace those, and I'll come back and test those in a minute. Okay, so we'll start with D1, and the value for D1 is a IN540. Pop this one out, and you'll notice on the board these have to go in the right way around, and they're marked with the white band which matches the band on the diode. So these can sometimes get quite hot, so what a lot of people do to replace them is just leave them few millimeters off the top of the board, I guess, to get airflow and so it doesn't damage the PCB underneath. So you just leave it slightly risen like that. Off. Now we'll replace R1, which we know is damaged, and this one is a 2.2 ohms. So it'll be one of these here. Let's just take that one out. Some long nosed wires for this one because it's hidden underneath the relay. So you can see there it's quite badly charred, which is quite a common fault on these. Can be a bit fiddly, get the first leg in. And the second. And pull those tight. That's nicely bedding on there. And then finally it was one of the diodes I wanted to replace, and these are, which one was it? It was D3, which is a 1N401, so one of these. So we'll take D3 out. To be fair, it's uncommon for these ones to go. I've had to replace a few in my time. Generally they're okay. So again, being a diode, they need to go in the right way around, and you can see there that it's marked on the PCB which way these need to go. Good, solder that one in. Okay, so now we've got the suspect components replaced. The next thing to do is check the voltage regulator to make sure that's not been blown due to the fault on R1. So that's this here, this 3-pin voltage regulator, and what you have is you've got ground on the centre pin and on the back, and then you should have 12 volts and plus 5 volts on each of the outside legs. So for this I'll connect this up to 12 volts. If I can find the power supply there. Okay, that's powered up. I haven't replaced the fuse yet, but the 1 amp fuse should control the relay coil, so it shouldn't affect checking the voltage. The 5 volts in this voltage regulator supply 5 volts to the pod, so even though the pod may be illuminating, it may not be getting enough for it to work. So let's put my meter there. So we put this on volts DC. We'll check our 12 volts in. So we're just on 12 volts going in. So I'll leave the earth on the earth pin, and then we'll just check the 2 legs. This voltage regulator. So you can see you've got 5 volts out that side, and just under 12 volts in that side. So this looks good. So I think this is going to be okay. If not, if you were to replace this, you're going to actually have to drill this rivet out, unsolder the voltage regulator, and generally just put a small screw and a nut in there to hold it in place. So I'm quite happy with that. There's nothing much more I can do with that apart from connect it to the pod and test it. But the next step I think we'll do is we'll test the pod and see if the pod's okay. So I'll just disconnect the control board for now and put that over there. Let's have a look at the pod. Most common thing on this, R21 gets burnt out. This one looks okay. You can check that with a meter quickly. So it should be, I think it's 10 ohms. So yeah, we're reading 10.1 ohms. So that's good. That's not been burnt out. Dry joints on the LEDs. If you get some of the LEDs don't work, they commonly go dry underneath the board and need resoldering. Other than that, there's another voltage regulator here. Very rarely go, but I've had to replace 1 or 2 now and then. And unfortunately, the worst problem is if the ULA is damaged. These aren't replaceable, although I do make replacement modules based on an Arduino, which can be fitted in their place. But you need to do a small modification to the control box for this to work, and then it should function as the original ULA. So all is not lost, but with a bit of luck, this ULA will be fine. So what I'm going to do now is I'm going to connect it up to a pod tester. And let's see how the pod's doing. So the connections on the back are a little bit dirty, they're not the worst I've seen, but the most important bit is looking at these joints here, looking for any cracks in those joints, and that's really common. And you can either try and clean those up with a bit of ethanol, alcohol, and reflow the solder on them, or if worst case scenario, I generally just replace these connectors and put a new one in. Okay. So the pod tester will test all the functions of the pod. We've got the motor start switch, we've got the current voltage, which if we lower then we should see battery drain registered on the pod. We've got, so that adjusts the voltage level. We've got the thermistor setting, so we can take the temperature right up so we can see the 2 lockouts. So the first is the warning with the beep and the second is the lockout, and the motor should go off. And then the third one we can adjust to check the current load, and we should see the left current load indicator go up and down depending on where that is. So let's turn this on. So it looks good. So we've got a full bank for battery on the right, 2 LEDs on the left, which is great. So if we turn on the motor, we'd expect to see the first green illuminated, which we've got. That's good. And then as we increase the motor load, that should cycle up all the way to red. So far this one is looking pretty good. So the next thing we'll do is we'll check the thermistor. So if I now slowly turn this up, we should see this flash and then a beep unless I go too far, which I usually do. Okay, that's not looking good, so I'm on full now. Okay, all may not be lost. This may not be the ULA. This could still be a bad connection, poor connection on the bottom of the pod. As I've got the voltage set to 10.4 volts, we can see the battery drain start to go down, so that's fine. So I'll just stop now. I'm going to clean up those connectors and then we'll plug it back in and test it again. Okay, so just had a look at the bottom of the connector, and although the joints actually look pretty good, don't know how easy it is to see on the camera, there is a lot of corrosion, certainly on this pin number 1. You can see it's lost all its plating. So to be honest, I could try and clean that up, but you'd probably go down to brass and then it would corrode even more. So the best thing you can do in this case really is just replace the connector. Easiest way to do this, because I can't get my desolder tool down the long legs of the thing, is just to take them straight off. And then that allows me access with my solder gun, desolder gun. The only other thing to be really careful with this is not to have it set too high, because these boards are quite old. So I'll reduce that a bit. It's possible to lift the tracks off the board, which isn't unfixable, but it's certainly an inconvenience. We should be able to just carefully lift that connector up. You may find some pins jam, that's fine, we'll deal with those as we get to it. The plastic piece will come off with most of them. Yeah, pin 1's jammed, a couple of them are jammed actually. Just lift these ones out of the soldering iron. Give that a quick clean with some alcohol. Okay, so we can see here on this one, this has lifted up. It's not quite broken. So we should be able to salvage that. Okay. So put a new connector. So we want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we take one pin out, pin 2 is not connected. Just be mindful of that one pin as we go back in with the connector. That's the new connector in. Right, let's just solder that up. Just have a little visual inspection of those connections, make sure I've soldered those nicely. So they look good. So again, I'm going to give them a bit of spray, get rid of all the flux and have another good look at them. So I'm not too happy with the one. Needs a bit more solder this side. There we go, that's much better. And what we'll just do is we'll just check that connection's good before we put it back together. So let's put my meter back on. Diode setting. And we can check pin 1, good, pin 2, good, pin 3, good, pin 4, good, pin 5 comes down here around the wall, so this one. Good. This was our one that was slightly iffy. This comes around here, down to here. So that's good. And this one down. I think it's that one. No, it's not. That's good. That one's good. Okay, so I'm happy with that. So I'm pretty happy all those connections are good now. New connector. So I suspect if the thermistor doesn't work now, it could be a ULA fault, unfortunately. But we shall see. So let's plug it back into the tester. still got current, and now hopefully so that's full cutout, so somewhere slightly before we should get a single LED and a beep. There we go. So basically it was quite simple faults on this one. It's literally just the connector, really common. There's a lot of people say in the group, try and clean it, replace the connector. I guess because it's exposed to the elements, it's prone to be corroded. Other common fault, R21, but as we can see in this one, it's fine. So that's it, I'm happy with the pod. So we can put that back together. And then let's hook it up to the control board and see if we're good to go. So pod's good, let's clear some space, let's get rid of the pod tester. Okay, so the only last thing we need to do on this control board is we notice that this fuse is blown. So this is the 1 amp fuse and this drives the coil on the relay. So doesn't often blow. If it does, you've either got a short somewhere or the coil in relay could be burnt out. So let's see if I got some 1 amp fuses. Pop a new fuse in there. 3 amp is for the lighting circuit. One of the things with these is people say that they've connected it up and the headlights work but nothing else lights up. That's usually because you wired it the wrong way around. Because the original light bulbs can be wired either way around, the lighting circuit continues to work even when it's connected the wrong way around. But generally you're going to blow R1, possibly the voltage regulator, and if those don't blow quickly you can also do some damage in the pod. So we'll throw that away. There's little bits of metal like that on your shorts. Right, so we'll hook up power. I need to find a wiring harness. What we got? So I'm not sure, I'm gonna have to check. I don't know if the thermistor on this one is any good. If not, I have some resistors in connectors which I tend to use instead. Right, so what are we doing? So the thermistor goes on pin 1 and 2. And we want a thermal cutout, which is this one. Then the main connector. And pod connector. connect the pod up to the other end. Okay. So in theory, if that will behave itself and sit up, let's put the power back on. Let's connect power supply. That always helps. You see we've got pod lights, so hopefully we'll have a relay click as well. Yeah, we do. So we're all good. So most of the faults with this set really were on the control board. Minor issue with the connector on the pod, which I've replaced. Yeah, we're good to go. Fuse one's fine. Everything's good. So this one's ready to go back. So I'll leave it there. I hope this has helped anyone that's diagnosing the same problems. I'll try and do some more videos when I get some more in, because they all have numerous different faults. And there are other components I do have to replace sometimes. This is probably the most common one. If you see R1 burnt out, this is usually your issue. Thanks for watching. I hope it's helpful.